Hello, good morning friends. Myself M. Vijay Kumar, working as Assistant Professor in Department of E&C STMCT Dharwad. I will be handling electromagnetic theory for both third sem A and E division and B division. The subject is electromagnetic theory. The subject code is 18U ECC 300. Sorry, it should be third sem A and B division. The contact hours for this subject is 52 hours, and it is better to use headphones or earphones for better quality of the audio for this lecture. In the lecture 1, I am going to cover these topics: the introduction, the syllabus, course learning objectives, we also call it as CLOs, course outcomes, we also call it as COs, program outcomes, POs, the content of the syllabus, the reference books, we'll also see the reference books, what books we are going to use, the evaluation procedure and the QP pattern, and the next we'll see slight brief introduction to electromagnetic theory, that is EMT. Then we'll start with the unit 1, the vector analysis. For making this video lecture, I have referred to several resources, online resources. So I would like to thank all the knowledgeable persons around the world from whom I have collected the various online resources. So my heartfelt thanks to all of them. Thank you. And I seek the permission through this media to use these online resources for my presentation. During the subject, if the students, if you have any queries, please contact me through my mail ID vijaykumar.sdmct@gmail.com. While asking the queries, please mention the lecture number, the topic, slide number, and the time slot in the video lecture. The slides and the video lectures will be shared privately in the Google Classroom. Yes, we will see the syllabus of electromagnetic theory. So course learning objectives, also we call it as CLOs. Here in this course, the course will focus on the theory and applications of the electromagnetic fields. The course concentrate on the study, interpretation, and applications of Coulomb's law, Gauss law, Poisson's and Laplace equations, Maxwell's equations in the study of electromagnetic fields in different media. And this course has 5 COs, that is course outcomes. So these each and every CO is mapped to particular unit that I will be telling you later. So first CO1 is mapping to the first unit. So understand the significance of vectors and solve problems in various coordinate systems. The CO2, derive the expression for electric field due to various types of charge distributions using Coulomb's law, Gauss law, and apply divergence and curl for studying the nature of electric fields. And CO3, define energy and potential and analyze the properties of current flow through conductors, dielectrics, using Poisson's and Laplace equations. Discuss CO4, discuss the concepts and laws governing the study magnetic fields. Then CO5, apply Maxwell's equations in understanding wave propagation theory. Then prerequisites for this subject. Okay, before just I will take the pen. I'll take pen. Yes. The prerequisites for this subject is basics of electronics and electrical engineering, and you should be having the background of strong background of mathematics, that is integration, differentiation, and you should be thorough with the vector algebra. That in the first chapter we'll study the vector algebra. The contents, just I will read the titles, and we'll be studying each and every unit in detail later on. So the first unit 1 has first chapter in unit 1 is vector analysis, and second chapter in unit 1 is Coulomb's law and electric field intensity. It is of 10 hours. Then unit 2 is of 12 hours. So first chapter is electric flux density, Gauss law and divergence, and second chapter in unit 2 is energy and potential. In unit 3, once again there are 2 chapters. First one, it is of 10 hours. First one is conductors, dielectrics and capacitance, Poisson's and Laplace equations is the second chapter. In Unit 4, once again there are two chapters, totally of 10 hours. The study magnetic field. Then second one is the magnetic forces and boundary conditions. In Unit 5, we have once again two chapters, time varying fields and Maxwell's equations. Second chapter is wave propagation, totally of 10 hours. Yes, coming to the reference books. Most of the times this one book is sufficient. The first one, that is Haight and Buck is the author. Engineering Electromagnetics, the publisher is Tata McGraw-Hill, and you can use either the 7th edition or you can use the 8th edition, one and the same. And remaining that is the reference books 3 and 4. If you want in-depth knowledge of the electromagnetic theory, then you can refer reference books, that is 3 and 4. 4 is also a good book, Sham Outline Series. So you can refer for various several numericals or worked examples. And one more book in order to get the n number of worked examples, you can refer the field theory by Bakshi. So evaluation procedure and QP pattern for this subject goes like this. So CIE evaluation, that is continuous internal evaluation, it is for 50 marks. This 50 marks is distributed for in IAS and CTA. So 20 mark for the IA. Okay, just I will be telling you. The CTA means course teacher assessment, it is for 10 marks. So this 10 marks is allotted by taking the quiz for 4 marks, the assignment, several assignments for 4 marks, discipline attendance the class 2 marks. So this is how the course teacher assessment marks are split. And IA1 is conducted for 20 marks. The portion for IA1 is first 17 hours roughly, the first 17 hours from the syllabus. The question paper pattern for IA1, all the IAs, IA1 or IA2 or IA3, the question paper pattern is 3 questions will be asked. Question number 1, 2 and 3. You can answer either question number 1 or question number 2. There is a choice between question number 1 and 2. Question number 3 is compulsory. One question is compulsory. And IA2 is also for 20 marks. IA3 is optional, but you can write it. But the best of two IAs will be considered. That is for 20 plus 20, that's 40 marks, and remaining 10 marks is CTA. So totally the CIE evaluation is for 50 marks. For semester end examination, that is SEE evaluation, it is for 100 marks. And the question paper pattern goes like this. Part A, it consists of 20 marks. In part A there are 2 questions. Question number 1, it is objective questions, that is totally 10 questions will be asked, each of 1 mark. And in question number 2, we can ask either 1 question or 2 questions, that is analytical questions for 10 marks. Then part B, remaining part B is for 80 marks. There is question number 3 to question number 7, that is 5 questions will be asked in part B, each of 20 marks. And each 20 marks questions will be taken from every unit. Totally 5 units are there. So from every unit will be taking 20 mark. That is out of 5 questions, there is one choice, you can answer any 4. Resources for this subject, not only for this subject, you can refer NPTEL video lectures for almost all the engineering subjects. Then coming to the introduction to electromagnetic theory, you can see that 1 minute, just okay, fine. We have the coordinate axis, x-axis. The electromagnetic waves are propagating in x direction, and you can see the electric field that is represented by E vector and the magnetic field represented by B vector, they are mutually perpendicular to each other. The electric field will generate, the time varying electric field will generate the magnetic field. Similarly, vice versa is also true. The time varying magnetic field will generate the time varying electric field. So you can see the propagation of electromagnetic wave or EM wave in the x direction. In the x direction, you can see here, right, in the x direction. Then the electric field, the time varying electric field and magnetic field, they are moving mutually perpendicular to each other. But here in this subject, we will not be studying the time varying fields. We will assume that the fields are stationary, means we will study the static electric field and the static magnetic field. We will try to understand how they behave, then we will go for time varying fields. Then you are familiar with the electromagnetic spectrum. As we move from left to right, the wavelength the frequency increases and the wavelength decreases. You can see, means as I move from left to right, the energy content of the electromagnetic waves goes on increasing. And you can see the electromagnetic, first the radio waves, then will come the next comes the microwaves, radio wave, microwave, then comes infrared, it is not shown here, infrared, then the visible light, then the ultraviolet rays, X-rays, then the gamma rays are radioactive sources. So all these will form the electromagnetic spectrum, and they are in the range from 0 Hertz to 30 E Hertz. 30 E Hertz. So the naming of this subject, some people refer to this as electromagnetic theory and some people as field theory, one and the same. So here in this subject we are going to analyze the static electric and magnetic fields. Already I have static electric fields and static magnetic fields. So in order to understand complete understanding of any of the electric circuits, we require the knowledge of two subjects. One is the network theory and another one is the field theory or electromagnetic theory, in order to understand the complete behavior of the electric circuits. Example, most of the power that is reaching the load in the electric circuits is in the form of electromagnetic radiation. So just I will consider one electric circuit here, simple electric circuit. This is the source, then this is the input resistance Ri, then I will consider the load, okay, fine. The current is flowing in the circuit in this direction through the load. So most of the power that is flowing through the load is in the form of electromagnetic waves, means this is the load resistor RL. The power that is delivered to the load, most of the power that is delivered to the load is in the form of electromagnetic waves, means just I will show the pattern how the electromagnetic radiations will be there. So this pattern just I will draw it. Okay, okay, the just I will place the conducting wall here, conducting wall on both ends. This is the conducting wall, conducting wall. So this will form an obstruction for the flow of electromagnetic waves, means if I remove the conducting wall, so almost all of the maximum power will reach the load. If I place the conducting wall here, then there is a obstruction for the flow of electromagnetic waves and the power reaching the load will be reduced. So here what I mean to say is most of the power that is delivered to the load is in the form of electromagnetic radiation, and some part of the current will be flowing through the wire. So in order to understand the complete working of the electric circuits, the knowledge of network theory and the field theory is essential. So we'll start with the first unit, that is vector analysis. Here what we are going to study in this first chapter, that is vector analysis. Here we are going to study first the vector analysis, that is in this the vector algebra, means addition, subtraction, multiplication and division of vectors. Then the three coordinate systems, the rectangular coordinate system, cylindrical coordinate system and spherical coordinate system. So all these things we are going to study in this chapter. Okay, first vector analysis. It is a purely a mathematical subject, but this forms the basis for the remaining chapters in electromagnetic theory. So we will be studying this, and vector analysis uses some symbols and set of rules. So vector analysis is a mathematical shorthand, means instead of writing vector A, simply I can make use of the symbols or notation. Just I will write A and put bar over it, so that is vector A. I can read it as vector A. So vector analysis is the mathematical shorthand. So this acts as a mathematical shorthand. So vector analysis form the basis for study of electromagnetic theory. Yes, that we'll see later on. Then significance of vector analysis. Yes, we'll try to analyze what is the significance of this vector. So vectors we'll see. For example, force acting on an object in different directions. Let me take an object here, one circular object or any object. So let me assume the force acting in the downward direction, that is 4 units, and let me assume another force is acting on this object, that is 3 units, right? By looking, this is the object. So totally, if I ask any common layman, he will say 4 units plus 3 units, totally 7 units of force is acting on the object. But it is wrong here, because we have to see the resultant force acting on the object. So the 4 unit is acting in the downward direction, 3 units is acting in the rightward direction. So the resultant force acting on the object can be found out using the vector analysis, vector algebra, that will see. One of the vectors I will draw here. See here, I will consider the vector acting the down 4 units, and another vector, this is the tail of a vector and this is the tip of a vector. Then I will consider another vector. Once again I will start with the tail of the vector and tip of the vector. This is 3 units. The resultant force acting here will be in this direction. Yes, the resultant force. And by using the Pythagoras, this is 90 degree. So by using the Pythagoras theorem, we will find that it is of 5 units, because under root of 3 square plus 4 square, that is root of 25, that is 5 units. So 5 units of force will be acting on this object. It is not 7 units. Okay. So thus the vector analysis will form the has its role in analyzing what is the amount of force acting on an object. Yes, I hope it is clear to you people. Then all of you know the difference between scalars and vectors, you have studied. So first we'll define scalar. Scalar is defined as a quantity which has only magnitude but no direction associated with it. This quantity whose value is represented by a single real number. It may be a positive number or positive real number or negative real number. So examples of scalars are the object falling a distance L in time t, the temperature at any point in a bowl of soup. Yes, if I consider a bowl of soup, the temperature at the bottom is maybe slightly high as considered at the surface. So I will not say the temperature at the bottom of the bowl or in south direction, or so I will associate at that particular point it has its value. So next, other set of examples of scalars are mass, density, pressure, volume and voltage. Then next, coming to the vector. Yes, we can define the vector is a quantity which has both magnitude and a direction in space. Example is force. Yes, force acting on an object, we have taken force acting on an object in which direction and what is the magnitude of the force. So both magnitude and direction are associated with it. Similarly, the velocity and acceleration are vectors. Here we study the 2-dimensional and 3-dimensional analysis of fields using vectors. Okay, next, what is field we have to define? Mathematically, field is defined as function of a vector which connects an arbitrary origin to a general point in free space. I will consider an arbitrary origin. This is the origin, so whose coordinates are 0, 0, 0. If I consider 3-dimensional, so this is the value of x, y and z, and that free point, it can be here, here, anywhere in the space. Let me consider, so which connects an arbitrary origin to a point in the space, either this point or this point. So it is a function of a vector which connects an arbitrary origin to a general point in space. So the concept of field is related to a region, okay, and it is spread in the space. Example of the field is the force acting on a compass needle due to the Earth's magnetic field. Yes, it is a very good example for the field. Then we can classify the field into two types, the scalar field and the vector field. We will not concentrate much on the scalar fields. We will concentrate on the vector fields. Examples of scalar fields are the temperature throughout the bowl of a soup. Yes, we check what is the temperature at each and every point in the bowl of a soup and we will not associate the direction for it. Then the density at any point in the earth. Yes, if I consider at the center of the earth, it may be very dense. it may be in the middle somewhere below the depth of 1 kilometers the density may be low. So density at any point in the earth is a scalar field. Then coming to the vector field, the gravitational and magnetic fields of the earth, yes, it is a vector field. Gravitational fields always it is acting in the downward direction, right? Because it's associated with the direction, hence the gravitational field is a vector field. And magnetic field, yes, suppose if I take the permanent magnet, it has north pole and south pole. Always the direction of the field is from north to south. Then voltage gradient in a cable, yes, always the current flows from higher potential to the lower potential. Voltage gradient in a cable will form I'm sorry, is a vector field. Then coming to the next topic, that is vector notation and scalar notation. Okay, first vector notation, how to go sorry vector notation and scalar notation. First, yes, there should be some notation in order to identify. I will represent the scalar quantity by some letters. For example, yes, if I want, let me take letter A. Yes, if I write, I will write like this: scalar A, scalar B. Then this is the representation for a scalar quantity. If I want to represent any quantity as a vector, let me use the letters vector A, and I can put bar over it, or else I can take letter A and put arrow mark over it. And in the textbooks, instead of writing vector A, some people will write in bold. Yes, they will write in bold, means it represents a vector A. So they will represent vectors. Vectors can be represented, that is vector A, bar over it, or arrow mark over it. So this is the notation for vectors. The notation for scalar is A comma B, just small letter. In textbooks they use the italic vector A like this, vector A italic, the textbook, what are they in the head and back, and there are several other notations if you refer other textbooks. So the coming to the representation of a vector, yes, I will consider one point here. I will call it as O, origin 0 comma 0 comma 0, and I will consider another point here. Let me call it as A. It may be having some, if I consider three-dimensional coordinate system, a point A is having x, y, z. It can be 1 comma 2 comma 3 or some other thing. Okay, so and I will associate the direction for it. So vector OA, I will write vector OA, or else I will write simply vector ROA. I can use either OA vector or ROA. So other than origin, it can be point A also and point B, and I will join from point A to B in this direction. So this vector can be AB vector, or else I will use the notation RAB. Okay, fine, RAB. Okay, the next, sorry, yes, tail and tip of a vector. Yes, just I have drawn one vector here. Yes, this is the vector. This we call it as tail of a vector, and this we call it as tip of a vector. Yes, the distance, so we will see the distance vector, position vector, and unit vector. Suppose I will draw a vector. If one of the point is origin, and if I have any point in the space, then this is the position vector. Always one point will be origin for the position vector, and I can write it the position vector as OA vector, in order, or else I can write the small letter R and letter A simply. It is by default understood the starting or tail of a vector is origin and tip of a vector is A. The small letter R, bar over it, vector, so vector RA vector or OA vector. Or else coming to the distance vector, yes, other than origin, I will take point A here, I will take point B here, Yes, point A to point B. This is the tail of a vector and tip of a vector, and I have set the direction here. So I can write vector AB. This is the distance vector. Distance vector means the 2 points are in the space. So both the points are in the space, and they are not at the origin. So another notation what is used in height and buck is R vector, capital R, RAB vector. So we will be using this notation for position vector, and we will be using this notation for distance vector. And unit vector, yes, for this vector OA, what is the unit vector? It is means unit vector is a vector whose magnitude is unity, but it will show us the direction. So along vector OA, the unit vector is, so just I will mark here, the unit vector is AOA. I will use the small letter A, AO to A. This is the unit vector directed along the vector OA. So similarly, the unit vector directed along AB is AAB. So this is the notation what we are going to use, vector AB, AAB, small letter. So position, just I will brief out R, first point, second point, and this is for distance vector. And for position vector, we will use the small letter R, and so the first point will be origin, will not mention here, and will mention the final point. So let me take it as A. So this is RA vector, and unit vector is a vector which is directed along in the given direction. So we will use small letter, and if the points are A and B, the unit vector is AAB vector. I hope it is clear. Then coming to the vector algebra, yes, already we are familiar with this vector algebra. Briefly I will tell. So here the vector algebra, we will be studying the addition of vectors, subtraction of vectors, multiplication of vectors, and division of vectors. So addition of vectors, we will be using the parallelogram law of addition or triangle law of addition. So you will see the addition of two vectors will obey the CAD laws, that is commutative law, associative law, and distributive law. Okay, here you can see there are, suppose let me consider two vectors, vector A plus vector B. I can add them in either direction, vector B plus vector. This is commutative law. Suppose if I have three vectors, vector A, it can be added in this fashion, vector A plus within bracket vector B plus C, within bracket vector A plus B plus C vector. They can be either added in this. This is associative law. So distributive law will be covered later. So I'll stop at this moment for the lecture 1. So I'll be covering the addition of two vectors using parallelogram law of addition and the triangle of addition in the next lecture. Thank you very much.